Alright, so in this problem, I have 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. So to solve this, I'm going to factor out 2 to the power of 10. So I get 2 to the power of 10 times 1 plus 1 is equal to 2 to the power of x. And 1 plus 1, that's equal to 2. So I get 2 to the power of 10 times 2 is equal to 2 to the power of x. And now if I divide both sides by 2, I get 2 to the power of 10 is equal to 2 to the power of x divided by 2. And 2 here, this is the same thing as 2 to the power of 1. If I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of 10, this is going to equal 2 to the power of x minus 1. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 10 is equal to x minus 1. Now if I add both sides, 1 on both sides, I get x is equal to 11. And now to check, my original equation was 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. X is 11, so I get 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of 11. And 2 to the power of 10 plus 2 to the power of 10, that is 2 to the power of 11. So this is right. Alright, so in this problem, I have 3 to the power of n minus 2 to the power of n is equal to 65. So to solve this, I'm going to first start by rewriting 3 to the power of n as 3 to the power of n to the power of 1. And I have minus 2 to the power of n to the power of 1 is equal to 65. And anything to the power of 1 is itself. So 3 to the power of n to the power of 1 is simply 3 to the power of n. Now, I'm going to rewrite 1 as 2 over 2. And 2 over 2, that's 1 again, so it's the same exact thing. And I'm going to do the same for 2 to the power of n. So now the reason I did that was because if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So n times 2 over 2, that's the same thing as 3 to the power of n over 2 times 2. Or sorry, to the power of 2. And the same thing for this. Now I'm going to let 3 to the power of n over 2 equal a, and 2 to the power of n over 2 equal b. So now I have a squared minus b squared is equal to 65. And a squared minus b squared, that's the same thing as a plus b times a minus b. And 65 I can rewrite as 13 times 5. So I have a plus b times a minus b is equal to 13 times 5. And we can say that a plus b is equal to 13 and a minus b is equal to 5. So now I have a system of equations. And to do this, I'm going to cancel these two out, add a and a, so I get 2a is equal to 13 plus 5, which is 18, meaning a equals 9. And if a equals 9, I can go ahead and plug in back to this one of these equations. I'm going to do here, so I get 9 minus b is equal to 5, meaning b is equal to 4. So a equals 9 and b equals 4. Now remember how we let a equal 3 to the power of n over 2. So 3 to the power of n over 2 equals 9, meaning n is equal to 4. And 2 to the power of n over 2 is equal to 4, meaning, again, n is equal to 4. So this is my solution. All right, so in this problem, I have x to the power of x to the power of 6 is equal to 144. So to solve this, I'm going to start by taking the power of 6 on both sides. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. And this is the same thing as a to the power of n times m. So x to the power of x to the power of 6 to the power of 6, I can actually switch these two places. So now I have x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal to the variable y. And now, because we have 2x to the power of 6 over here, I can simply substitute in y for x to the power of 6 into my equation. So if I do that, I get y to the power of y is equal to 144 to the power of 6. Now what I'm going to do is rewrite 144 as 12 squared. So now I have y to the power of y is equal to 12 squared to the power of 6. So now what we're going to do is, remember how we have this property. If I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m, as well as a to the power of n times m. So I have 12 to the power of 2 to the power of 6, and this is the same thing as 12 to the power of 2 times 6. And 2 times 6, that's equal to 12. So I have y to the power of y is equal to 12 to the power of 12. And if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, y to the power of y is equal to 12 to the power of 12, meaning y is equal to 12. And now remember how we let x to the power of 6 equal to y. So I have x to the power of 6 is equal to 12, meaning x is equal to 6 root of 12. Alright, so in this video, I'm going to solve the problem 15 to the power of 50 over 3 to the power of 25. So to solve this, I'm going to first start by rewriting this as 15 to the power of 25 plus 25. So we wrote 50 as 25 plus 25 over 3 to the power of 25. And the reason I did this is because now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So in this case, 15 to the power of 25 plus 25 is going to equal 15 to the power of 25 times 15 to the power of 25. And I have this over 3 to the power of 25. And now this is equal to 15 to the power of 25 times 15 to the power of 25 over 3 to the power of 25, which is equal to 15 to the power of 25 times 15 over 3 to the power of 25. And this is equal to 15 to the power of 25 times 5 to the power of 25. Now another property of exponents is that if I have something from a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this is going to equal 15 times 5 to the power of 25, which is equal to 75 to the power of 25. So this is my answer.